Hi guys, I'm Shivam Joshi. I'm back after a very long time. So, without any further ado, let's get started with our today's video's topic, thermodynamics. Thermodynamics is a very vast subject and my favorite subject. Thermodynamics engulfs many things, and if we go on a very broad perspective, it engulfs everything you know. Everything can be explained using thermodynamics. Every physical phenomena, every energy transfer phenomena, every momentum transfer phenomena, even mechanics can be explained using thermodynamics. Every fundamental process has its roots in thermodynamics. I'm not exaggerating, it's the most fundamental subject because it deals with energy transformation. Energy is the only thing that makes up this universe. We know energy mass equivalence and everything. That equivalence has constructed all the mass and all the energy in this universe. Thermodynamics studies its transformation. Hence, study of energy transformation is thermodynamics, and everything is comprised of this energy only. Hence, everything comes under study of thermodynamics. Okay? The thermodynamics is very vast, but it explains the complete phenomena based on only three laws. Zeroth law of thermodynamics, first law of thermodynamics, and second law of thermodynamics. That's it. Everything explained in three short laws. These are very, very simple laws. We are going to cover them in different videos, but I'm going to state them for the clarity purpose, completion purpose. First law is the zeroth law, which states the thermal equilibrium and differentiates between thermal equilibrium and temperature equilibrium, or thermodynamic equilibrium and thermal equilibrium. First law is about the energy, which is very well known. Energy cannot be created and now be destroyed. The second law, the third in the sequence, I will tell the story about it in the zeroth law video. The second law of thermodynamics has two statements, Kelvin Planck and Joule. Kelvin Planck statement and not Joule, it's Clausius statement. Kelvin Planck statement and Joule Clausius statement. Kelvin Planck statement explains the working of a heat pump, and Clausius statement explains the working of a refrigerator. Those statements are not intended for heat pump and refrigerator, but still they are basically and most widely used for heat pumps and refrigeration. I will be taking the Clausius statement which he originally wrote down. Okay, both first law and second law. They are much more interesting than the original, than the textbook written law. I will tell you that in the second law video. Now, what thermodynamics, all these laws explain some quantities. Okay, they are about some quantities, that some quantities cannot take some values, some quantities cannot go beyond certain criteria. But what are the quantities? The fundamental quantities like energy, various forms of energy like heat, work, pressure energy, flow work, many types of forms, and I said quantities and entities. Quantities come many things like mass, density. Quantities are in physical forms. Entities like enthalpy, these are names given to some group of quantities like PV plus H equal to U plus PV. I will be taking that in further videos, but still you need to understand the difference between quantities and entities. Okay? What is the direct application of thermodynamics? Thermodynamics is basically applied everywhere, as I said earlier, but most prominent application of thermodynamics you will be seeing in thermal industries like power. Power is the basic application of thermodynamics laws and everything. Thermal industries, which are like most famous example, Thermax. It's related with boilers, steam is produced in the boilers, then steam condensers, heat exchangers. Many of you might be thinking that heat exchangers might be coming under the heat transfer. You are correct, heat exchangers come under heat transfer, but the basic fundamental law remains the same, which is under thermodynamics. Okay, many nuclear power plants. Okay, nuclear power plants, you might argue that nuclear power plants work on a very different basis, but power generation is based on thermodynamic cycles. Thermodynamic cycles, these are the most widely covered parts. Like many types of cycles are there. Joule cycle are there, Brayton cycle are there. I have covered some cycles in my earlier videos. The most important, Carnot cycle is there. So these all cycles, they are used to either generate power, they are used for many other purposes, for refrigeration purposes, for heat pump purposes, many other purposes. So all these cycles are utilized directly for either power in the sense electrical power, or internal combustion engine which develops motive power. But all the basic fundamental lies between thermodynamics only. Jet propulsion is the most fast application of thermodynamics. It is as fast as Mark 3, Mark 4. It goes up to there. And I'm not talking about MARK, I'm talking about MACH, okay? Mach, as many people may call it. Jet propulsion is there. Gas power cycles is also there. I'm covering it up. Gas power cycles are there. And many indirect applications that you can think of. Many indirect applications. I'm not capable enough to take all the examples. I'm not capable enough, but still I may not be exaggerating enough. Yes, I'm not exaggerating. Thermodynamics encompasses everything that you see, understand, and basically can be explaining. Means anything that can be explained using thermodynamics. Basic. That's it. So that's it, guys, for today's video. We are going to cover up all these topics. Like this is the video on thermodynamics. I'm going to take some videos on thermodynamic laws. I'm going to explain all the quantities separately. I'm going to explain all these cycles separately. You know how we do about cycles. We have done it already. So we are going to see everything breaking down to pieces and easy to digest. We are going to do it. So guys, if you like this video, please hit a like and subscribe to my channel. Guys, share this video. Thank you.